Assalamu alaikum and welcome to all of my viewers. Today is 3rd of May and I am dealing with chapter number 7, that is related with the circle, and in the circle we are having a theorem, and the statement of that very theorem is the tangent at any point of a circle is perpendicular to the radius through the point of contact. So in order to explain the statement of the theorem, first of all we have to consider a circle. Let's consider it as, here it is a circle. So in the circle, what we have to prove? We have to prove the tangent and the radius, they are perpendicular to each other. Let's consider this as the center of the circle and denote it with the point O, and draw a line from center to any point on a circle. Let us consider a point here, and let's consider this point as point P. So OP is the radius of the circle, and then draw a tangent like this. As you people are aware about the tangent, tangent is a line which touches the circle at one point only. So that point is the point P. So this point P is here known as the point of contact, because this point is common between circle and the line. So that is why this line is known as the tangent. And consider this tangent as AB. So AB is a tangent and OP is a radius of the circle. And what we have to prove? We have to prove this OP, it is perpendicular, rather it is always perpendicular to the tangent AB. So what we have to prove, we will write it as, to prove OP, it is perpendicular to AB. That we have to prove. So this radius, it is perpendicular to AB through the point of contact at point P. We have to prove it. And before going through the proof, let's have a construction. In construction, we will draw any segment from point O to the tangent AB other than P. Or we can say like this: a segment here from point P that will touch your tangent at point Q. Let's consider this as point Q, and let's consider this as point R here. So here once again, OR, it is the radius, and this OP, it is the radius, but OQ, it is greater than the radius, because this is the point which lies outside the circle, and this P is the point which lies on the boundary of a circle. That means with the circle, within the boundary of a circle, at the boundary of a circle, we can say it. P, it lies at the boundary of a circle, and this OQ, it lies outside the circle. So OQ, it is greater than your radius, it is greater than your OR, it is greater than your OP. So in construction, simply we will write it as, take any point, and that is point Q. Take any point, and that is point Q, other than P, other than P, and join it with center. Join it with O. Once we join it with O, then we will take the proof. In proof, we will say this OQ, or first of all, we will say this OP, it is equal to OR. Why they two are equal? Because they are the radii of the same circle. OP is the radius, OR is the radius. So OP and OR, they are the radii and radii of the same circle. That is why OP is equal to OR. So we will write radii of same circle. Radii of same circle. But this OQ, it is equal to OR plus OQ. OQ line segment, it is equal to OR plus OQ. So it means OQ, it is greater than OR, because OQ, it is equal to OR, that means radius, plus a bit more than that, that is RQ, this part, RQ. In other words, we can say OQ, which implies OQ, it is greater than OR. So OQ, it is greater than your OR. Or we can say, once again, this OQ, once it is greater than OR, this OR and OP, they are equal, so it is greater than OP. If we will change the order, we will write OP, it is less than OQ. So OQ, it is less, OP, it is less than OQ. So this OP, it is shorter than OQ. It means OP, once it is shorter, but shorter than to any other segment, whatsoever the other segments which are drawn outside the circle on the tangent AB, that will be greater than your OP. So we will write OP is shorter than any other segment joining O, this O to tangent AB, to tangent AB. It means as we are aware, once we are having a shorter side will always act as the perpendicular, and this is the shorter than to what? Shorter than to any other segment which is drawn from O to the tangent AB. If we will draw another segment like this, this OP will be shorter than this. If we will draw another segment like this OP will be shorter than this line segment. So any other segment except excluding this segment OP, that will be the greater than this your OP radius. So we can write OP is a shorter than any other segment joining O to tangent AB. In this manner, we can write it as OP, it is perpendicular to your AB. Hope you understand it very well. Thank you.